To get the product of sum formulas, I'm going to use the sum and difference formulas. To get sine, what I'm going to do is I'm going to subtract this formula from this formula, and I can do that because these two sides are equal. When I'm subtracting these formulas, this side is equal to this side, so I'm subtracting an equal amount from both sides. I know that tends to confuse a lot of people sometimes when people just start subtracting formulas for each other. But it's the same as adding 1 to both sides or adding 10 to both sides. As long as an equal amount is added or subtracted or multiplied from both sides, it's fine. And in this case, this side is equal to this side, so I can just subtract these formulas. So that's what I'm going to do. I'm going to subtract this bottom formula. Well, it doesn't really matter. Yeah, I'll just subtract this bottom formula from this top one. So if I subtract, I get cosine alpha minus beta minus cosine alpha plus beta is equal to this minus this. So these terms are going to cancel out because these are both positive. Cosine alpha, cosine beta, these are going to cancel out. And this is, since I'm subtracting this is going to turn into a positive sign. So I'm going to have 2 sine alpha sine beta. And then I just divide this by 2, and I'm going to get sine alpha sine beta is equal to 1/2. Let's do it this way. And this is the product to sum formula for sine. I have a product of two different sines, sine alpha, sine beta, and this formula converts this product into a sum. So if this was, I don't know, 10 and this was 5, then I'd have 5, or wait, yeah, this is 10, so 10 minus 5, 5, 10 plus 5, that's 15. So I'm left with the product of two sines, then I'm left with the sum, well in this case they're being subtracted, but the same idea, the sum of two cosines. So that's the idea of these formulas. And then if I change this into a plus, then I can get the product of sum formula for cosine. So instead I'll be adding these together. Whatever, I'll just do it over here. So cosine, well, let's do the same order, alpha minus beta plus cosine alpha plus beta. And this is equal to, now I'm doing an addition. So these terms are not going to cancel out this time, and these terms will cancel out. 2 cosine alpha minus beta, or alpha, 2 cosine alpha cosine beta. And then I just divide like last time. Cosine alpha cosine beta is equal to 1/2. Cosine alpha minus beta plus cosine alpha plus beta. So that's the sum and difference formula, or that's the, not the sum and difference, the product to sum formula for cosine. And then there's one more. If I were to have a product of a sine and a cosine. And for that I'm going to use these formulas, the sum and difference formulas for sine. And what I'm going to do is I'm just going to subtract this from this. This, well, actually we'll do it the other way. Yeah, we'll do it the other way. It's just to avoid a minus sign, but I can do it this way or this way, it doesn't really matter. I'm going to subtract, I guess just imagine that this was down here and I'm subtracting. sine alpha plus beta minus sine alpha minus beta. Now I'm subtracting this top term, so these terms are going to cancel out. This minus will become a positive, and then I'll have 2 cosine alpha sine beta. And then it's just another division by 2. Real simple. I could have added these if I wanted to, but it really doesn't matter. It all amounts to the same thing. So here I have a cosine of some angle and a sine of some other angle. And they can be the same angle, I guess. Just use the formula. It doesn't really matter what the angles are. If I have a product, I can turn it into a sum. And I'm not going to go over the tangent ones. At this point, it should be fairly obvious that if I want a formula for tangent, I just take my sine formula, and just divide it by my cosine formula. So from now on, I'm not going to bother with tangent. It's just a waste of time. It's a waste of space in my brain memorizing, or even just bothering to learn these. Just whatever sine is divided by whatever cosine is. That's it.